apprentice and the dark. I was scared of pretty girls and starting conversations. All my friends are turning green. Yeah, the magician's assistant in their dream.
The Vancouver Island marmot is one of the most endangered species in Canada. In the 1990s, it was estimated only 30 individuals remained in the wild, and research attributed this massive population decline to predation.
I'm gonna win ya. I'm gonna get you one way or another. I'm gonna see ya. I wanna meet ya.
Previous research focused solely on predation as a source of decline, but failed to examine how human impact or climate change could affect marmots. Increased predation could have been caused by human activities. For example, the logging industry could have displaced predators from their natural habitat, forcing them to higher altitudes where they began eating marmots more frequently. Our proposed research will examine how or if climate change has an impact on marmot hibernation, length, and dispersal distance. First, here are some facts about the Vancouver Island marmot. Marmots live in family groups called colonies and hibernate below ground with their colony from mid-September until late April or early May. However, studies have shown in recent years marmots are emerging 28 days earlier from hibernation, and this may be related to climate change. Marmots live in metapopulations. Metapopulations are a collection of local populations that contain the same species but are separated by space. Individuals regularly move between populations by dispersal. These small colonies are largely made up of closely related individuals, which leads to a lack of mate selection. Therefore, dispersal is very important as marmots will leave their natal colony and disperse to find a mate. When dispersal is restricted, this can result in increased levels of inbreeding, smaller effective population sizes, and a loss of genetic variation. Overall, this can affect population stability and persistence. In order to examine if climate change is having an impact on marmot dispersal and hibernation, the following hypotheses will be tested. The range expansion hypothesis will test if earlier emergence from hibernation will result in a greater dispersal distance. It is predicted with greater dispersal distances, mate finding will be less successful. Dispersing marmots are less likely to find a mate as dispersing greater distances will deplete crucial energy stores, decrease their body condition, and make them more susceptible to already elevated predation pressures. This will lead to a decrease in effective population size, a decrease in genetic variation, and an overall increase in population vulnerability. The range compression hypothesis will test if earlier emergence from hibernation will result in a shorter dispersal distance. It is predicted with shorter dispersal distances, mate finding will be more successful, as the marmot will travel shorter distances using up less energy and will get to safety quicker. This will lead to an overall increase in effective population size, an increase in genetic diversity, and a more stable population. The neutral hypothesis will test if earlier emergence from hibernation will have no effect on dispersal distance. So, how will these hypotheses be tested? First, sites will be surveyed where records indicate regular occupancy in the past 20 years, as well as range-wide surveys of open and high-elevation habitat, which marmots select for. This will establish current and recent marmot distribution, and the information will be used to determine where colonies exist within metapopulations. Second, individuals within colonies will be captured, tagged, and tracked via radiotelemetry to determine hibernation length and dispersal distance. Third, environmental factors will be recorded upon exit from hibernation, including the average temperature and snowpack. These will be used as indicators of climate change and compared to data from previous generations. So, why is this research important? Currently, there is a massive conservation effort being undergone to save the Vancouver Island marmot from extinction. Part of this conservation effort is the National Captive Breeding Program, which involves partner facilities across the country. Marmots are being bred at 4 different facilities. These are Calgary and Toronto Zoos, Mountain View Conservancy Centre, and the Tony Barrett Mount Washington Marmot Recovery Centre on Vancouver Island. Marmots are then selected from this program to be reintroduced into the wild. This is a vital and costly program for the welfare of the marmot species, and our research could help provide helpful information for marmots being reintroduced into the wild. For example, optimal distances and optimal latitude of colonies can be decided. We greatly appreciate your consideration to fund our research and the Vancouver Island marmot.
Run, boy, run. This world is not meant for you. Run, boy, run. They're trying to catch